A remarkable new discovery has captured the attention of both scientists and space enthusiasts worldwide, igniting widespread curiosity. Bill Nye, a well-known advocate for science, recently announced something groundbreaking. Voyager 1, humanity's furthest spacecraft, has detected over 300 enormous objects in the vast reaches of space. This unexpected revelation has intrigued many, sparking questions about the nature of these objects and their origins. In this article, we will explore the mystery behind Voyager 1's astonishing discovery and what it may reveal about the deepest parts of our universe. For nearly 5 decades, the Voyager missions have stood as a testament to human exploration. These spacecraft have given us incredible insights into our solar system and beyond. What's even more remarkable is that these missions were never meant to last so long. Back in the 1970s, scientist Michael Minovich proposed a radical idea: spacecraft could use a planet's gravity to propel themselves even further into space. This concept of gravity assist would allow spacecraft to travel faster and farther without using additional fuel. Originally, the Voyager missions were expected to last just 5 years, but they far exceeded all expectations. Voyager 1 and Voyager 2, launched just weeks apart in 1977, were tasked with studying Jupiter and Saturn, two of the most mysterious planets in our solar system. They succeeded in this mission, sending back remarkable data and images. But the journey didn't end there. Voyager 2 went on to perform the first close-up studies of Uranus in 1986 and Neptune in 1989. These missions earned Voyager 2 the title of Grand Tour, but it didn't stop there. Instead of wrapping up, both spacecraft turned their attention to something even more ambitious, exploring the uncharted vastness of interstellar space. Now, 46 years later, both Voyagers continue to collect critical scientific information from the farthest reaches of space, far beyond where any spacecraft has ventured before. In 2013, NASA announced that Voyager 1 had officially entered interstellar space, beyond the Sun's magnetic influence and particle streams. This momentous milestone marked the first time a human-made spacecraft had crossed into this unknown region. Voyager 1 was now in a space far beyond our solar system, like stepping from a busy city into the quiet solitude of the cosmos. Then, in 2018, Voyager 2 crossed into interstellar space as well, further expanding the reach of human exploration 17.7 billion kilometers from the Sun. Now, Voyager 1 and 2 are humanity's only explorers in interstellar space, offering rare insights into the region between stars. They are studying how the solar wind, charged particles flowing from the Sun, interacts with the interstellar medium, the diffuse gas and dust that fills the space between stars. These spacecraft have become the primary sources of data on the heliosphere, the protective bubble that surrounds our solar system and shields us from harmful cosmic radiation. One of the most surprising discoveries was related to cosmic rays, high-energy particles that continuously bombard space. Voyager's data revealed that cosmic rays are 3 times more intense outside the heliosphere than inside, offering us a glimpse into the dangers lurking in interstellar space. Imagine the difference between the peaceful atmosphere of a backyard and the chaotic energy of a busy street. This is the comparison scientists make to describe the intensity of cosmic rays beyond our protective barrier. But there's more. In 2023, Voyager 1 recorded an unusual, faint sound, like a low hum, coming from the vibrations of small gas particles drifting through interstellar space. This discovery gives scientists a new way to study the properties of the interstellar medium. The Voyager spacecraft NASA has had to make difficult decisions, shutting down non-essential systems and even turning off heaters meant to protect the instruments from the extreme cold of space. Despite these obstacles, all 5 key instruments on both spacecraft have kept working since 2019, far surpassing their expected lifespan. This incredible feat continues to puzzle scientists, showing just how resilient these spacecraft truly are in such harsh conditions. Even more fascinating is the shifting nature of the heliopause, the boundary between the solar wind and the interstellar medium. The heliopause is not fixed in place, instead, it shifts and fluctuates, raising intriguing questions for scientists. Over the last decade, researchers have been using data from the Voyagers and NASA's IBX satellite to track these shifts. One of the most unexpected findings occurred in 2014, when IBX observed an unusual surge of energetic particles, suggesting that the structure of the heliopause was not as expected. This discovery has caused scientists to reconsider their understanding of the solar system's outer boundary. In May 2023, Voyager 1 experienced a strange event. Its Attitude Articulation and Control System, ACS, which controls the spacecraft's orientation, began transmitting erratic and confusing data. This led to concerns that the spacecraft was having difficulties communicating with Earth. However, Voyager 1's radio signal remained strong, and its scientific instruments continued to work perfectly. Eventually, NASA discovered that the UX had been using an old, inactive computer, and they solved the problem by switching to a working system. While the cause of the anomaly remains unclear, the spacecraft itself is still operating smoothly. As Voyager 1 ventures further into interstellar space, it faces challenges from high-energy particles, which can cause small memory errors in its computers. These particles interact with the spacecraft's electronics, leading to accumulated errors over time. Susan Dodd, the project manager for both Voyager missions, explained that such anomalies are to be expected, considering how long the spacecraft have been in operation. Voyager 1 and 2 have crossed unimaginable distances and explored regions of space no spacecraft had ever been before, all while operating with outdated technology. Their computers, designed in the 1970s, have only 70 kilobytes of memory, less than most modern-day digital devices. Despite these limitations, NASA has managed to keep these spacecraft running, sending back invaluable data from the farthest reaches of space. Sending software updates across these vast distances is no easy task, but NASA's Deep Space Network ensures that communication with these explorers remains possible. The Voyagers are now so far from Earth that it takes more than 22 hours for a signal from Voyager 1 to reach us, and nearly 19 hours for Voyager 2. Their signals are like faint whispers from the farthest reaches of the cosmos, barely detectable amid the noise of Earth's technology. Yet, they continue transmitting crucial data, a testament to the incredible endurance of these missions. Reflecting on the Voyager missions, it's hard not to admire the incredible achievements they represent. The idea of using gravity assists was a game changer, and NASA's decision to take advantage of the unique alignment of the outer planets allowed the spacecraft to make their way to Neptune faster than expected. Despite the constraints, NASA's decision to launch these spacecraft in the 1970s led to the extraordinary success of both Voyager 1 and Voyager 2, whose legacy will last for generations. These spacecraft will continue to inspire us, reminding humanity of the boundless curiosity and unyielding